These are notes for 6.8, page 545 for Math 60, Friday, March the 20th. Question 11 deals with a homeowner who can do a roof job in 7 hours and a professional who can do it in 4 hours. How long would it take for them to work together? So if we let X be the number of hours, if both of them work together, then if you consider what happens in 1 hour, well, in 1 hour, the homeowner would finish 1/7 of the roof because it takes him 7 hours to do the entire job. And the professional would do 1/4 of the work because he can do the whole job in 4 hours. So if we take the 1/7 plus the 1/4, that would equal 1 over x. Multiply both sides by the common denominator, which is 28x. Multiply this by 28x. Multiply this by 28x. We get 4x plus 7x equals 28, or 11x equals 28, or x equals 28 over 11 hours combined. So a little bit under 3 hours, but more than 2 hours if they work together. Problem 15, we have something similar. The numbers involved were 10 and 14, so we put the reciprocals just like in problem number 11. 1 over 10 plus 1 over 14 equals 1 over x. Multiply both sides by the common denominator, which is 70x. That gives us 7x plus 5x equals 70, or 12x equals 70, or x equals 70 over 12, which is 35 over 6 minutes. Problem 19, we have something similar, except we have a subtraction. The subtraction is there because of the fact that we're losing a certain amount of water due to evaporation. So setting it up just like problems 11 and 15, the 1/3 plus 1/5, however we have to subtract 1/10 for the evaporation, and that gives us 1 over x. Then the rest of the problem is pretty much similar. Multiply both sides by the common denominator, which is 30x, giving us 10x plus 6x minus 3x is equal to 30. 13x equals 30, x equals 30 over 13 weeks. Problem number 23, we have 1 over x plus 1 over x plus 6. We were given that one was 6 hours longer than the other, so 1 over x plus 1 over x plus 6 equals 1 over 4, because we were told 4 hours total. This time the common denominator is 4x times x plus 6, so we multiplied by 4x, x plus 6 on both sides, giving us 4 times x plus 6 plus 4x equals x times x plus 6. Clean all this stuff up, continue up here. We end up with a quadratic equation, 0 equals x squared minus 2x minus 24, which factors into 0 equals x minus 6, x plus 4. By the zero factor property, that gives us x equals 6, or x equals negative 4. For this kind of word problem, we don't want negative answers. So x is 6 hours, and we add 6 to 6, we get 12 hours, so 6 hours and 12 hours. Question 31, we set up a box using distance equals rate times time, which also means time is distance over rate. So both going and returning, we have 75 miles. However, for going, we put x, and returning, we have x minus 10, because this is 10 smaller on the return trip. Since time is distance divided by rate, I take 75 divided by x, put it in this box. 75 divided by x minus 10, put it in this box. Okay. Now, 75 over x plus 2, because this was 2 hours quicker, so I need to add 2 to this side to get an equality, equals 75 over x minus 10. Multiply by the common denominator, which is x times x minus 10. Comes out to be 75 times x minus 10 plus 2x, x minus 10 equals 75x. Clean all that stuff up, factor out, and we get x equals 25. Reject a negative root. So x is 25, 10 less than that is 15, so going was 25 miles an hour and back was 15 miles an hour. For problem 37, something similar. We're told the plane goes 600 miles, the car 240 miles, and I called the plane's rate of speed x, and the car would be x minus 90 because we're told it goes 90 miles an hour slower. Time is distance divided by rate, so I divide 600 by x, 240 by x minus 10, and in this case we're told the two times are equal. So since the two times are equal, I set this equal to this. In other words, 600 over x equals 240 over x minus 90. Cross multiply, 600 times x minus 90 equals 240 times x, which is back up here. Distribute, combine like terms, and we get x equals 150 miles per hour.